Hi.
Hey. So yeah, we were just discussing a few issues that we discovered over the past few days when we were testing out the P2P mempool. One thing of importance is that, I mean, we already noticed this on the description with PVG, which surprisingly all the bundlers use the same, what do you say, the tracer, but the values turn out to be different. And Skanda reports a much lower PVG. As a result, Cilius seems to be rejecting those user ops. We need to, identify what's causing it or how we address this. Obviously, on one side, we can set up a markup to ensure um, uh, this doesn't happen, but we don't know what's the root cause for the issue. So that's something we'd have to investigate. Dror, a question to you. Is it okay if we were to track all these issues that we identified directly on GitHub and ETH Infinitum, or should we just use a private spreadsheet for now? What would you prefer?
It can be on. There's no problem in putting GitHub issues for that. On which repo? On the test repo you wanted to put it?
I don't know. Which one would you prefer? That's the question we had.
It's an integration issue. I'm not sure where to put it. It's a
Yeah.
Let's collect it in the page and then see. Okay, because for one thing, right now there is no test for pre-verification gas. Specifically,
Correct,
check
yeah.
that value is what is supposed to be correct, because we never really define it. We had also talk about gas estimation with Dan. Yeah, it is a topic that it's a hairy topic. It's complex, even if we agree on accepting one user per bundle, because if we do require bundles, then the numbers change depending on the size of the bundle. So
yeah.
I don't have a clear idea of what is supposed to be, or we tried to think, but we haven't got into any conclusion, so there's nothing about it. How to incentivize bundlers to use big bundle. If we could, in a way, incentivize bundlers to do it, then it would help. But right now, the only way is that it's going to be some consensus on what size of bundle we calculate against. Let's say right now we calculate against 1 because this is the de facto standard. Later we calculate against 5. This is the privilege is supposed to be valid for 5, but then what would happen if the bundle turns out to be smaller? Then will the bundler be will have to accept this bundle even though it is less profitable? It will probably not be non-profitable, because there is still also the priority fee, but it will not. The pre-verification gas will not cover itself.
Yeah.
It's something that it's never the top priority, so we're always pushing it aside. But yes, I mean, it's something we need to address. The idea that in the long run, when we know that there is a market for user ops and there are bundles, and bundles stabilize on some given size, then we could say that, okay, we have to calculate it based on, I don't know, 10 or 20, because actually above 10, the difference is going to be very small.
Yeah,
like we know the overhead is like 40K, so above, I think, maybe I'm wrong on that, a few tens of Ks, the static overhead. And the 21 of the transaction itself, a little bit of the entry point, so something like 40K. Yes, and paying the beneficiary at the end. There are few static things. Now, if a bundle is above 10 items, then the error margin becomes much smaller. So yes, at one point we will need to say that This is the defined minimum, and bundlers should return an estimate with a little factor just to cover the possibility of some fluctuations. And of course,
Right.
users will try to abuse that and try to find the absolute minimum and send that, and either or not be surprised when it is not propagated through the mempool, because for a user, it's impossible for you to know if it's got propagated through the mempool.
Yeah.
So
Yeah.
So yes, so testing. So yes, we should have a PR and add tests to the framework. It's
Okay.
the static, not even the P2P. Maybe also in the P2P add those tests, but the specific per bundler handling is not in the spec test.
Okay.
Yeah, I think it's probably important for us to at least just have a common equation that we're using to calculate for it. But things to keep in mind, one, pre-verification gas is what bundlers use to pay for L2 call data today, and that's a dynamic value. So when we spin up mempools on L2s, that's going to become a problem. Like it's just going to be a static value. So, or sorry, a dynamic value that's moving. So in general, there is just going to be some amount of, bundlers needing to add overheads and kind of take a little bit of the responsibility for helping their users set values that the network will allow them to land bundles with. So I think definitely we need a test to make sure that, like, okay, for simple static pre-verification gas for a single user operation bundle, this is the calculation, so that we can make sure that at least that works well. But the network's going to need to be pretty resilient to pre-verification gas changes.
Yeah.
The way,
and then with regard,
yes, it's very easy to do it resilient. Is we define the minimum.
Yes.
Tell all bundlers take a markup on top of that for the users.
Yeah.
This is how to be resilient. I can't think of any other way we can be resilient.
Yeah.
Well,
all we need to define
the problem is there's
sorry.
no minimum. Like, because as you said, as you bundle, it actually gets smaller, and for the dynamic gas, it changes for at least for L2s. So
no.
Yeah.
When we okay, I see what you mean, Dan. But given that at least as of today, all these values are determined by the tracer, wouldn't it help to determine why, even though we're using the same tracer, different bundlers come up with different values? If we probably address that, then the minimum, the defining the minimum for the PVG should be sorted, right?
So the PVG is not, you don't use the tracer for it. It's just a calculation based on the contents of the user operation.
Yes. By definition, it's not something you can calculate on chain. It's only something that is calculated off chain. So the tracer doesn't help you there.
Is that the case? My understanding was different. I thought we were collecting some portion or using the tracer some way or the other for the PVG. If I stand corrected, if we're not using the tracer.
I'm not sure I return in the tracer these values. Some of the stipend and call data cost can be visible during tracing, but I'm not sure that our tracing return these values. PVG, by definition, is what you can't calculate on chain. So you need to calculate. You have the initial gas limit, and then on chain you get less because some of it got the stipend and the call data. So this is a. Yeah. Formula. The point is the constants we put in. And yes, L2's dynamic gas makes PVG the only place we can place the gas requirements. which quite abuses it. Yes, that's true. That's unfortunate.
Yeah.
Because the alternative, if we could have a good definition of a gas, we could add another one, but we are quite reluctant to add yet another gas limit. We're already at 5 for different stages, so it would be best if we could stick to that. We are thinking mainly for native, for a gas limit for things that you don't calculate based on gas, because gas is cost of putting things on chain. But if you think about heavy validation, which account abstraction has more heavy validation than normal transactions, these are not denominated in gas. These are denominated in a CPU cost of validation. So we thought of adding a fee which is not related to gas, but
yeah, I would love for native at least, because in the native implementations we'll have access to this L2 call data cost information as part of the VM. It'd be great to make that as part of the actual validation and not dynamic.
In native we calculate it in native code, so we can have different rules per network.
Exactly.
Okay.
Fair rules per network, something we can't do with the contract.
One quick point to make about pre-verification gas and bundling and incentivizing bigger bundles. One thing we've talked about in the past was basically saying users can actually submit lower pre-verification gas. Let's say the user exposes the preference to the bundler that they are okay with waiting to be bundled in a bundle that is of size 3, for example. It's kind of an arbitrary number because you don't know how long you're going to need to wait to be bundled in a bundle of size 3, but the bundler can then run the pre-verification gas calculation based on saying, hey, I'm going to bundle you at least in a bundle of size 3. Then we gossip that to the network, and then it's all of the bundler's jobs to create a profitable bundle based on top of that pre-verification gas. So in this scenario, they'll just put that user operation in some pending state until they see enough user operations that are willing to be put in a bundle to build a profitable bundle that includes that bundle of that requires, or that user operation that's required to be in a bundle of size 3. It gets a little complicated from like a solver standpoint, but that is one way that this could have been solved. Is like if whoever is rejecting that user operation could say, hey, I can make a profitable bundle. I just need to wait for a second user operation to come along, and I can create a bundle of size 2, and this user operation becomes profitable again inside that bundle. But I think we're a little bit of a ways off from actually getting that to work.
What we're talking about is like some kind of a multi-dimensional gas calculation, and there are better reasons for do multi-dimensional gas calculation than bundle size, because it's going to. There is a talk about it regarding L2s of the L1 gas cost and L2 gas cost, and they're thinking about multi-dimensional. It's problematic over there, and it's not. And adding yet another dimension just for that, I don't think it suffers. So the way to wait, I think, shouldn't be based on the bundle size, but keep using priority fee for that. If you are willing to wait, put a lower priority fee. Bundler will check the overall gas over revenue it will make. Yes, it includes PVG. It also includes the gas calculation of the profit of the transaction. It doesn't know the full transaction, but it knows a minimum. It knows the validation, and it knows that it will get at least 10% of the gas limit of the transaction. So a bundler can have a very good estimation of, or quite good estimation of how profitable this user portion is without looking into the pre-verification gas. So in theory, it could take the pre-verification gas, ignore it completely. Like, sorry. In theory, it could accept a user operation with zero pre-verification gas because they pay enough with priority fee. In
Right.
theory, no, but I don't want. As a spec, we define that pre-verification gas should cover the fixed costs. Why? Because we don't want the system to be too variable. So yes, this value, user operation will not be accepted if the pre-verification is below some minimum. And we can say that this minimum is like for a bundle of 10. Right now, it's not written as like this in the spec. This I'm thinking about it. So that there is a minimum pre-verification gas. It should be good enough. The bundler can't exploit it too much. Like, okay, I'll put you in a bundle of 100, and then I won because you paid little extra. And for smaller bundlers, the bundler will do what it always does. It checks how profitable is this user operation is. And in the future, when this bundler is also a node, a block builder, compared to other transactions, I take the overall revenue of this transaction and put it in the list of priority with anyone else.
Yeah, I think this dynamic, this like calculation based on bundle size becomes even more important when we talk about aggregators. So you still have this issue of like, how do you price the signature aggregation work, and how do you disperse that across the various user operations in the bundle? And I think it comes down to the same sort of equation here, where a user needs to be able to specify some preference of like how big of a bundle they want to be put into, by specifying lower gas limits. So saying I'm only willing to pay up to this much of pre-verification gas. And so, you know, when you're in an aggregator or you're paying for call data that says, hey, I have to be in a bundle of size 5 or else my pre-verification gas is going to be too small for you. And then the bundler just runs some sort of solving algorithm that says, hey, this thing is just going to be put to the side until I can create a bundle of size 5. And that's a trade-off the user makes from a latency perspective.
Okay. But this might work on the bundler side, but yeah, sorry, go on, Shaf.
No, I'm sorry. I just had another call with actually like talking specifically about that, about the pre-verification gas and what it takes into account and the bundle size and everything. Okay, so no, it's just go ahead. I was just talking about it on a different call. Yeah, so go ahead, Pata. Sorry.
No, I was just saying for the context, it was an issue that we discovered during the testing of the shared mempool, where user ops were considered valid on one bundler, were rejected on the other because of a lower PVG. We were just working out what is the best approach we could take to ensure at least probably set a minimum PVG that all bundlers could report, and we are just working out different suggestions. So to come back, Dror, you're happy for us to raise this issue on the bundler spec test repo, and then we have a discussion there and then agree on what would be the ideal approach, right? You're okay with that?
Yes. And by the way, Dan, regarding the aggregators, yes, you're right, but before starting using aggregators, we need to understand how much, what is the call data cost is going to be, because as of it is right now, there is no use case for aggregation, for signature aggregation.
Agreed.
I did some calculation in the past for BLS, and it was for BLS 254, not even the new BLS signatures. The one we have in the reference implementation, and on Arbitrum with a factor of 2000 between L1 and L2 call data costs, which was like a reasonable factor at the time I was checking, you need a bundle of at least 10 to be break even. So
yeah, I would love to run that number on with an aggregated snark, though. I feel like that could change the.
yes, snarks are not as easy to use as BLS for creating.
Oh, totally. I agree. I mean, it's a lot more of a bigger experiment.
And a lot of off-chain calculation. Yeah. Okay, I didn't do it on Snark. Snarks might change it because I'm not sure how much does a Snark verification on chain, how much its cost in terms of gas varies with different size of the bundle. Because with BLS it's linear. You have like 80K per user operation for pairing, and then another 300K for the actual signature verification. That's a huge amount. And again, it only it requires a huge difference in cost. I need to check whether it's worth it.
Yeah, I would say this sort of thing is becoming more interesting. I think looking out, I know there's been a few proposals for these key store rollups, key store storage, and these are all going to be based off of some sort of snark that on an L2 that proves over, key inclusion on some with and taking in that L1 state root, and so that only becomes economically viable really with some sort of signature aggregator. So I do think signature aggregation is going to be interesting sooner, but I do agree we don't have the order flow to make signature aggregation worthwhile, which is kind of why I'm been considering at least this sort of way for users to expose a preference over how long they're willing to wait to get bundled to be put into an actual bundle, and what that bundle size should be, because then for signature aggregation they could say, hey, I understand that, hey, I'm only willing to pay this much gas, so you need to create a bundle of size 4 or else it's not going to be profitable for you as a bundler to do. And then that thing can just sit in the mempool and wait until the bundler can create a bundle of size 4. I'm not sure how to even implement that in a bundler. I think it's going to be a complicated piece of code. But I personally can't think of another way to actually even do signature aggregation, especially on low throughput networks.
Yeah, because before adding this to aggregation to a bundler, I'm trying to think of MEV bundler, trying to think how the entity, the PBS or whatever, the entity that propose a set of user operations and a set of transactions, how that would be implemented, even without aggregation, thinking about aggregation. Okay, probably that entity wouldn't think about aggregation anyway, because it doesn't care. It's only some gas saving. It's not much.
Yep.
Because I'm not sure how much technical complexity we should add to the protocol now in order to support optimal aggregation. Though, yeah, we still need to think about it.
Yeah, and I'm not even sure how much of this needs to be in the protocol. I think pre-verification gas can kind of continue to be treated as this like way for a user to just expose some static amount of gas they're willing to pay that is never going to change, and then that's basically what the builder, that plus the priority fee and maybe some MEV, is what the builder then solves over to create a profitable bundle. There is obviously from like a user experience perspective and working with different bundlers, there might be a more complicated standardization that we need to do to make sure that when users talk to different bundlers, they're not getting wildly different gas estimates.
Yeah.
So
we need to standardize these values. That's something we knew from day one. And the problem you describe in the mempool, we thought about it and we thought, yes, we need to solve it in order for the mempool to be viable. So we hit it now, which when we have a mempool, which is great. But we don't have a solution right now, but we do need some solution. As I said, like a minimum pre-verification gas calculated based on a bundle of size X that you must follow, then estimate return a higher value.
I have a question. So forgive me if I'm out of the loop in this call about it, but when talking about pre-verification gas, did you see a huge difference between different bundle sizes? Considering that pre-verification gas should take, while it is influenced by the size of the bundle in terms of the memory expansion, maybe if it gets there, or the size of basically the size of memory that is being allocated in envelopes, but it should be, I think it should be counterfeited to an extent by the intrinsic gas cost of 21K. Like the less user operations in the bundle, the more they should pay for that. No? So
I think the tests that we did was all for a bundle of size 1, and even in that we came across discrepancies across different bundles.
Ah, really?
And as
what was the delta? Like, what was the difference?
I think the check that when I ran the tests a few months back, I think we've seen a lot of differences. I'll have to look up that blog or the tweet that I published. I think there was a difference of at least 30 to 40, but this need not necessarily be because of the actual PBG that is reported, but it could be because hosted bundlers were adding an overhead in their estimates. So you don't know what it costs this.
I remember that estimation, that analysis that you did being on the verification gas limit, not on the pre-verification gas.
No, the PBG also had differences back then, and the latest one that we tested in the mempool was between Silius and Skanda. And there the difference was around 40 GUI, 40 units or so.
Oh, okay.
40 weight? No, it's not 40 GUI even.
Yeah, that's such a small number.
No, it's
but it's a small number, but that caused user ops propagated from Skanda to be rejected by Silius.
Understood.
Okay, that's because you estimate and specify the exact value you estimate.
Yeah.
Okay, so I think that we obviously need a standardized way to estimate pre-verification gas across bundlers. I'm not sure if that's the conclusion that we got to, and I'm just repeating it, or where do you stand?
Yeah. I mean, the idea of both Dan and Dror was that we should probably come up with a standardized calculation for each bundle size. Maybe if it's a user of bundle size 1, we specify a minimum PVG, if that is even possible, and let bundlers decide to add overhead if.
Yeah, I think that's a reasonable spec test to put in, to say, hey, PVG of a bundle of size 1, calculate, like, we should at least, if we're not setting a minimum value for that across bundles, there's going to be a fragmentation issue. But I will say, as this gets more complicated on L2s with dynamic gas, and then with bundle size varyings and aggregation and all that stuff, it's going to be a lot more complicated of a problem. But I think for today, it makes sense to have that minimum check.
Yeah, and what do you think?
And the other thing you raised, we need to. It's one thing to calculate it correctly, and the other thing is to define how L2s should add to that, to standardize on that. That's standardizing for each network, Arbitrum or for Optimism or others, because this is the only way they can charge. So
yeah, this gets. I feel like at a certain point you end up standardizing too much, and it limits the bundler's ability to like make its own local decisions. So it's a tough one. So gas estimation is a tough one in general, like across like how much we should standardize versus what bundlers.
I think maybe instead of standardizing the exact calculation, we should have some kind of guide to what exactly it should take into account with a sample calculation. Do you see what I mean?
Shahaf, like this. I submit a user operation to a bundler, and it accepts it. The point is that the calculation I used was very minimal, and the bundler was very permissive. But other bundlers think that my user operation might not always be that profitable, or that
right, because they have different bundle sizes, because they want to charge more. I get that there are different types of
even if you leave bundle size, let's say we all do it for one user operation.
So that I believe is an issue, because they probably take into account different. It depends on, okay, if we isolate bundle count and profitability, okay, if I don't know if that's a way for them to profit extra gas from the client, but if it is, then that's a different. That's not only pre-verification gas. That's also bundle fee basically. Okay, and that's a different issue. But assuming that profitability and bundle size is the same, I expect them to be roughly on the same ballpark, in my opinion. Okay, and what I mean by that is that if the client is willing to pay just a little bit over what he calculates as the proper pre-verification gas, the minimal one, if he's paying a little bit more than that, I expect it to include most of the bundles. And by expect, I mean that most sane bundles, or like most reasonable bundles, should get to the same calculation, to the same computation, like roughly the same. That's what I mean.
Let's take a step back. When I submit a transaction and I put in a priority fee, is there a reason for different block builders to accept that into the mempool or not? Because it could be that the node I'm talking to says this value is too low. It will not accept.
Yes, and that happens. That happens on mainnet as well.
Yeah, I'm trying to think, to a lesser extent. Okay, I'm asking, is it the same problem? If it is the same problem, then we should see how.
So I think that it's okay. This problem is like, in essence, it's the same, but now we are talking about numbers. It's like, if you that's the only thing that matters. If you have value and the same way, like a reasonable way that the client calculates pre-verification gas, and it actually gets like 70% of the bundle to agree on it, then you're okay. Then that's not an issue. If only 15% of the bundlers agree to your pre-verification gas, then that's an issue. Like, it really depends on the fluctuations of the pre-verification gas across bundles, and that's the part that maybe we should ask here, or not maybe, definitely we should ask Parta, Dan, and Vid, and other bundler writers what they think about it. Like, how do they think we should solve it?
Can I request that we probably do this discussion on the issue on GitHub so that it's better documented? At least we might end up overshooting our time limit of 1 hour for this call, because there are quite a few other issues that I would like to raise and discuss.
Okay.
I'll create an issue on a bundler spec test, and then I'll share that, and we can continue a discussion there, Shahaf. The other issue that we noticed was that the number of peers connected seemed to differ, or rather, Candid's bundler could not recognize Cilius, even though both of them are connected to the same boot node. We still don't know what's causing this. We are investigating. Sheriff, do you want to chime in and say what the issue is?
Yes. When connecting with Kanda, and I have actually tried multiple peers. Yeah, I can see that it's connected, that they are all connected. But I guess Celius is not showing it's connected. It's not discovered. When the bundler sends a discovery request, it doesn't receive it only receives one beer, which is Celius. And if I add another Voltaire beer, it also they see each other. So I'm not sure what is the problem exactly. Yeah.
Let me understand.
Okay.
Do you say that you never succeed to connect, or that above a given mempool size or P2P network, a new node is unable to connect?
Yeah, when the bundler it sends a discovery request each 2 seconds or each second. Okay, so it should see all the peers in the connected to. It's connected to. So it can discover scan the peers, and if I added another Voltaire beer, it can also see them. But the Celius bundler, it can't see it. I will try to run. I will try to diagnose this, but I'm not sure exactly why.
Should we probably run Celius as boot node and then try Voltaire connecting to Celius's boot node, and then you're able to find peers? It could very well be just compatibility issues between Voltaire talking to Celius. You never know.
Yeah, I guess, yeah.
Okay, so happy for me to create for this also in spec test, right? Because eventually all of these probably should be handled as P2P tests.
Yeah, I also need to do some work to make the P2P test also run in a batch.
Yeah.
By the way,
so,
did you start working on a V7 0.7 bundles, or are you still working only on 0.6?
No, it's only on 6 because at the moment the P2P support is available only for 3.6, not for 7.
Any timeline?
I'm told most of the teams would be ready with entry point 7 support probably mid of April, and I don't know about Dan, of course, but from what I heard from the others, it's like that. And then probably after that, we'll start adding support for P2P on entry point 7 as well.
Okay.
And the next question. Before I come to Fastlane's request, I just wanted to give an update. I had a chat with Bhargava, the security researcher at Ethereum, and he said he will create a list of tests, and but apparently he's busy with something else, and he said he'll come back to me in a couple of weeks to see when he can do the first testing of our mempool. Asked him all the details I have. I'm still waiting from him. Hoping to again, and that's on that side. And the question I had was on we've been, as you all know, talking to Fastlane for adding support or providing support for the conditional endpoint on Polygon, and that's the context for the question that I raised in the bundler group yesterday. I think apart from Pimlico, Christoph, everybody else seemed to agree on 1,000 USD as the thing. So are we happy to proceed with that as the minimum stake so that I can publish a mempool ID? Or the alternative is, if I have to discuss and deliberate further, I could just create a temporary mempool ID for now just to test Fastlane integration and revisit this later on.
Look, the number is not. yeah, the bundlers accept it. The idea is to prevent an life service, but the usability issue is for what small stake paymasters, stake deployers need to use. And he suggested the fact that I'm fine with either. What I do, by the way, what I do think we might need when we start, we can start like in 5,000 and then make it real. We're now switching to a new mempool ID because assuming someone attacked us and we need to switch to the 1,000 one.
Karta, do you said that Christoph is the only one that was objecting to 1K of USD stake?
Not
so,
objecting,
what was his objection?
Yes, even though he said it's not critical. I'm saying that maybe it's good to start low because one of the things we want to test is raising it, like new mempool ID.
Yeah,
which is most restrictive. So yeah, I don't mind.
Raising it's going to be an interesting process because all of those paymasters who decided to use 500 as their stake are no longer going to be valid on the 1,000 stake mempool. So then they're all going to have to go send a transaction to restake. So it's not like we can just like dynamically.
No, but this is exactly.
Do you have any stats on how many paymasters are there that are using 500?
This is exactly the scenario. Some bundlers, the flow is like this. Every start with 500 and happy about it. And then there is an attack on these bundlers. And these bundlers start feel annoyed because they're spending too much CPU. So they agree to switch to 1,000. Some bundlers have a bigger CPU, so they don't care. They do get transactions. So the cost of this annoyance is bounded for them. So they accept the one. So what happens is that the network now, the mempool, for some user operations is split. Some bundlers accept those user operations and also has to handle all this heavy load, and some bundlers don't. So, and if this group of bundlers who accept it become too small and diminish, yes, at that point, those bundlers, those stake paymaster has no other option, because before that they were included less because fewer bundlers accepted them, and now because of this attack, which essentially attacked them, someone attacked a low staking paymaster. By the way, it would mean that if we have a minimal stake, it could be that some people will say, you know what, I'll stake 2,000 because I don't care. Why should I have to run after my tail when for some reason the stake is raised? I will stake some reasonable value that I think it will be good for a longer time. So it's a change that we need technically to see that we can handle.
You know, technically we could have, technically we could even start with 2 mempools because we already have deduplication for alt mempools. So you could have you could have all the bundlers joining both a mempool for 500 and one for 1,000. And then if there is a denial of service attack, bundlers can drop out of the 500, but they are already on a mempool. So there is no. So for bundlers, there is no disruption. I think it might make sense to have like more than one setup for canonical. So you have 2 canonical mempool, and one is the fallback. So it only gets used because of deduplication. It only gets used if the other one is down. But the real problem is, as Dan said, the paymasters, because we have no way to communicate it to them. So if someone set up a paymaster and suddenly the user operations are not going through, they will have to figure it out. You know, say, okay, why are all of these user operations not going through? And they will not know who to talk to necessarily. There's no easy way to communicate it.
Look, there's going to be a channel between bundlers to communicate what is the preferred mempool, because
it will return an error. So it will say, you know, the stake is too low.
If there is an attack on the mempool, this is not something official. Actually, every bundle finds it by himself and acts upon it like drop from one mempool, but there is no official release that's saying there is semi-official maybe Telegram channel that will say so. A tool that might help if there's going to be a tool that can show bundlers and their support for mempools. If it is,
yeah, exactly, like
that is the
mempool visibility.
Yeah,
like something.
This is
like
a visibility tool that could help.
Yeah.
Again, it's not something official. It's not formal way.
It can
of
also
saying,
be like semi-official. It can be on our like domain or something like that. That you can see like the bundlers and the mempools. Like how many bundles are supporting what
yeah, of course. When I'm saying it's not official, it's not that we can check that and formally verify that there is an attack and this is why we are doing it. It's unofficial in that you trust the one who published this document.
Well, you don't really care about whether it's an attack or just an upgrade. Like the only thing you care about is what the availability of the mempool is.
Yes.
Like you have a mempool, how many bundles are supporting it? Do you have any? Yeah.
Yes. As long as there are few mempool IDs, it's gonna be fine. Once we have a large number because of whitelist and such, it's gonna be more complex. But yes, this is a nice tool to write a.
Okay, so then I'll publish two mempool IDs, one with 500, another with 1,000, and Fastlane.
Both.
Sorry,
yes.
go on.
I'm sorry, and yeah, publish two IDs, and everyone should actually join both, which also lets us test the deduplication mechanism for alt mempools because it uses the same thing. So we can launch the two IDs. Now, another comment I wanted to make regarding this, regarding Christoph's objection, is that if anything, a network like Polygon may require a higher stake, not a lower stake than Ethereum, because what we're protecting against is directly associated with it's correlated to the network speed. If you have a network that has very fast blocks and a lot more transactions, the bundler's CPU doesn't scale with them, which means that you need to protect them even better than you would on Ethereum. So the faster and cheaper the network is, actually the higher the stake needs to be.
And not exactly. Think about it. What the stake supports. The attack is a huge number of user operation pushed into the mempool and all gets dropped on the floor and blocking the paymaster. All paymasters, actually. Now, you spend your stake on this block. So you have the actual cost depends on the block rate. And since the block rate on the Polygon is 6 times higher than Ethereum, so the stake you need to attack for a given period of time is 6 times higher. So I did a small calculation. It's like if the 1,000 per block, you need $1.8 million to block the network for 1 hour. And when you reach 43 million, which is enough for a day, with the current stake rules and unstake delay, this is the absolute maximum. Well, by staking $43 million, you can block the network completely. But this is something we can easily fix. If we find out that someone tries it, we raise the unstake delay to 1 week or 1 month. And most users will not care because they keep the stake on. Only attackers will need to raise the stake by 10 times higher.
Yeah, it's much easier. It's much more friendly to paymaster developers to raise the time to raise the unstake delay and the amount. They don't care if it takes a week instead of a day to get it back, and it improves security. So yeah.
Real quick, I'm pretty sure that this falls under the case of something that the P2P mempool is not set up to actually do deduplication for. So if you have a user operation that uses a paymaster that has stake of 1,000, that would need to get gossiped on both the 500 and the 1,000 P2P mempools. And we're currently not set up to actually do deduplication across those two.
Yeah.
No. This is the difference between canonical and non-canonical mempool. Canonical mempool you publish on the first, and they are ordered.
Which one do you publish on?
the first one that accepts it.
So,
So-
do you publish on
Right
1,000 or 500?
It's right on the 1,000.
That depends
But
on
then
which is the
people who
canonical.
are listening
If
on
you
the,
take
but
the
people who are
lower one
listening on the
as
500,
Okay,
yeah,
so- Wait,
don't hear it.
Dan, why would the bundler listen on a 500 but not on 1,000? Like, why would he not want a higher stake? What's the case for that?
That is a good question. You're right. So the bundler, if the bundler's listening on the 500, then we can assume that they're listening on the 1,000. So then the bundler should only need to.
Yeah,
Okay.
It
Yeah.
only
Makes sense.
yeah. So
Makes
you
sense.
order them by stake, and
Yep.
Yeah.
I got it.
1,000.
The rule
Got it.
for canonical, the rule for canonical is like that. We publish a reasonable document, official document, that says all the canonical mempools you should support. You should start them one by one and send on the first one that is accepted. And they will be ordered by the most restrictive to the least restrictive if there is any overlapping between them. When
Yeah, that makes sense. I got it.
it is unofficial, so you send on every non-canonical mempool that it's supported because you don't know what is the mix and match. This is the definition. Canonical doesn't mean
Okay.
more than that. That's all what canonical means in our definition. It's the list we publish, they must support all the
Okay.
canonicals.
That makes sense. Hey, Partha, we've got like 7 minutes left. I was wondering if we could discuss like what's coming next for like ERC 457/ native account abstraction. All that, like now that 0.7's done, it's out. We've talked about the P2P mempool a bunch. We know what's coming there. I'm curious what the team's working on. When 0.8, like what's
so yeah, okay. Actually, can I want to ask a question regarding what you just said. So first of all, we are very much in tune with the community, and we don't want to keep having breaking changes for you and making your life difficult. So we are also discussing it, but a question that I want to ask is about actually the DevOps surrounding native account abstractions. I would probably want to reach out to some of you to help us out if you can with booting up something like bootstrapping something like that, like some kind of a small local even like DevNet and to actually check the native account abstraction. And that's something that I would like to get your opinion on because obviously you're much more experienced with DevOps on this kind of networks than us. So that's something that I would like to get your help for, if you could. Did you get?
Yeah, happy to chat whenever. Sure. Ask any questions you have about it. I think I'm not sure. So I'm from native account abstraction. I know at least. I mean, bundlers are going to at least have to make some updates internally to handle the new native account abstraction transaction format. So I'm not sure how close we are on standardizing that. That would be my only concern. Is that like?
Yeah, so that's a valid concern. I can tell you that we are adding support to our bundler for native. Now, it doesn't include a mempool yet, but I think that the mempool is the part that is going to be the least, that would have the least amount of changes. And it's not a big deal. Like it does have an overhead of work to also support it, but not by much. Like most of the code is relevant. Most of the code is going to be very similar. The flow is going to be very similar. It's mostly the structures and stuff like that are changing from the bundle side. So that's actually one thing that I would like. This is something that we would like to find out. How much of a task would it be for you? And that's something that we are doing currently ourselves. Once we are finished with that, like adding native support, native AA support to our bundler, then we can actually tell you what's necessary or suggest what's necessary.
Let me take it. What Shachar said. When we thought about a node, you usually is a monolithic entity like Geth or such. Now, with account abstraction, validation becomes much more complex and also has all these validation rules. So the entity that is called the bundler, even though that logically it's part of a node, we believe that separation of a node and a bundler that and an API between them is something that should be kept even for native. Right
Yeah,
now,
that's exactly, that's an advantage. We actually see it right now. Yeah.
Yeah, right now the bundlers talk with a node with no specific API, maybe send transaction conditional. With native, the API is going to be more intimate. Like, it's not that you talk to any node, it's a node and a bundler, and the same provider will provide both entities, but by separating them and have a distinctive API, means you can mix and match. The minimum changes, there are changes for the transaction type, of course, for the nodes, but you can use whatever bundler, a native bundler, to use it, and you can mix and match between a node and between a bundler. It's not that the bundlers are now gone and block builder does everything. It is a logic that will be 90%, 99% required, and it's better to be in a separate entity.
Makes sense.
So,
Yeah,
in the midterm, what is more interesting now that we have a different version, different incompatible version? Yes, we do need to see that the providers provide both. Simple things like, are we using the same API or using different API, RPC API endpoint? Probably different. I've no say either way, but yes, there is this change, and then trying to push it to the client, trying to push to a client and providers and SDKs, the upgrade procedure for accounts, how to seamlessly upgrade from one model of entry point to another, while making sure your account never get dropped in the middle. This is something we worked on. We now start to work with SDKs to see how to push it forward. This is why one of the reasons we want that there will be bundlers out there with 0.7, because, of course, nobody can deploy anything on 0.7 before there are bundlers. So it's not that the bundlers are waiting for the SDK. The SDKs are waiting for bundlers.
Yeah. But just
So
on
it
that
sounds
note,
like you guys are focusing on native as a group. That's like the next steps for 4.3.7 / just this style of account abstraction in general is switching to native.
Native was forced on us. It's not. We thought that account abstraction 4.3.7 is good enough. The point is that so many networks are looking for native. And
wait, Dror. That's I wouldn't say it like that, because there are advantages to having it native. For example, gas cost reduction, like on many operations over there. But I would say that there is a place for both native and non-native, simply because it depends on the network, and some networks are not that inclined to add any support for any account abstraction solution, and having like a protocol that is not native on top of it is still beneficial. So it's probably that they are going to be to be alive, both of them together, the native and the non-native. So the separation, this is also a case for the separation that we already have between the gas and the bundler. So that's it. But still, sorry, continue though.
No. What I'm saying is not that we are now moving our efforts to a native. We think we continue to work on both, and we think that 4.3.7 will stay for a long time here. We shifted effort into the native, even though we think it will take more time for it to get included, simply because we noticed that some want to use native and try to use their own incompatible one. So to push Starknet and zk-SYNC into more native support, or at least the idea is that wallet will be able to use account abstraction on multiple networks, even if it's not fully compatible like zk-SYNC. Right now, there is not a single wallet that supports both. There are two differences for a wallet to support both. So we do want that if anyone is going to do native, you should do it the right way. Not that because we are right and they are wrong, because we try to create a roadmap toward the native, and we want to make sure that a 4337 account will be able to easily upgrade it or even work both. Think about cross-network. When one network supports 4337 and the other supports native, and you want to do a cross-chain. So it's actually an account that supports both. So this is where we want it to be.
Yep.
It's not shifting away effort away from 4337. We fully committed to it, and we think it's here to stay, at least on someone, it's going to stay forever. I'm not sure if and when mainnet will accept it. It will take a long time. And people, and even then you're not used much, and you move everything you do to L2s, you still want to be able to have a cross chain support.
That makes sense. So what's next for 4337 as a protocol?
Right now, just stabilizing everything we have. We want to see the network, we want to see the mempool, we want to see the upgrade works, because the upgrade from 0.6 to 0.7, while it is required and it solves the security issues, it's a precursor to a future upgrade to a native. We hope there will not be any 0.8 specifically just for that purpose. We can't say there won't be, but the only reason to have it is some security issue.
An unexpected security issue, we do not want to ever break ABI again.
It's fine. Cool. And just quickly, two other updates. I'm told Linea will start supporting the conditioned endpoint soon, because basically we're making the changes. So we should be able to roll out as soon as they add support. I'm also talking to Scroll. They have reacted positively. I'm still waiting for a timeline on a turnaround time from them. So.
Cool.
I would also say that the other thing that we are adding, okay, what's next for 4337 is that that's not only the work on the protocol itself, on the protocol level, but also on the middleware, so-called middleware of wallets, having a better ecosystem. Basically, we are still in talks with different groups that most of you are aware of. Like, you are aware of most of them, I think. And yeah, so we are pushing it forward. It's not getting into a stagnant place or something like that.
Yeah, I think I've covered everything else I had in my points to discuss. Does anybody else have any questions? All right, cool. Have a nice day then. Speak to you all later.
Bye.
Bye, everyone.
See ya.
Bye.
Bye.